Okay. Hi, hello, and everyone. Welcome Ungalakaga Physics. And in this video, we will be discussing some questions in atomic and molecular physics. And I am changing to English because in most of the people request to upload video in English because it is better to get some technical terms simply. Okay, right. So this is our second video. This is part 2 of atomic and molecular physics, and in this video we will be having questions from hydrogen atom, Sommerfeld atom model, and positronium related questions, and we have Stern gel related topics in this video. Right. So the length of a semi-major axis of an electron in an elliptical orbit is determined by. So the idea of elliptical orbit was first put forth by Sommerfeld because the up to Bohr atom model we don't have idea of elliptical orbits. So the idea of Sommerfeld, the idea of elliptical orbit was given by Sommerfeld. So the length of a semi-major axis of an electron in an elliptical orbit is determined only by a principal quantum number. Okay, so when the azimuthal quantum number n phi is 0, the ellipse reduces to into a circle. Okay, so these are the outcomes from the Sommerfeld atom model. Right, if n phi and n are for an electron in an elliptical orbit are 1 and 2 respectively, the ratio of semi-major axis and semi-minor axis, since it's an elliptical circuit, elliptical orbit, we have this ratio b square by a square equal to n phi square divided by n square. Okay. So for a by b, we just write a by b is equal to n by n phi. In the case of here, we will be having n is equal to 2 and b is equal to 1. Answer is equal to option A. Okay. The principal quantum number and the azimuthal quantum number in the relativistic model of an atom are 3 and 1 respectively. Principal quantum number is n. This n is equal to 3, and we have n 5. N phi is 1 respectively. Then the magnitude of semi-major axis b, and in terms of semi-minor axis, the magnitude of semi-minor axis b in terms of semi-major axis a is given by. So we just write b by a. This is nothing but n phi by n. So n phi is 1 and n is 3. So we write semi-minor axis b is equal to a by 3. So this is how we get b is equal to a by 3. So option A is correct. Okay. Right. So next question. The wavelength of a first line of a Balmer series in hydrogen atom is lambda. First line we have lambda. Then the wavelength of the first line of this Lyman series. Okay. And then the wavelength of the first line of the Lyman series. Let's write for Balmer series. For Balmer series, so we have 1 by lambda is equal to RH 1 by 2 square minus 1 by n square. Okay, so since RH is same, once we are taking the ratio, RH will vanish. So I just write 1 by lambda is equal to 1 by 4 minus 1 by 3 square, which is 9. So here we have 9 4 36. We have 5, sorry, 9 minus 4. We will be having 5 by 36. So lambda is equal to 36 by 5. 36 by 5. So say in the case of first line of Lyman series, it will start from 1 by lambda is equal to 1 by 3 square minus 1 by n square. N starts from 4, and if we have RH here, so once we do this, we will be ending up with we'll be having 3 by 4 RH. 3 by 4 RH. 3 by 4 RH. Okay, so here also we will be having a RH. So instead of lambda, if I put, we have 5 by, just a minute. Okay, right here we have to find, this is lambda. So this is lambda. If I multiply this with any of this term, we will be getting 3 by 4. Okay, so that will be the correct option. So let me do check with we need 3 and 4. We need 3 and 4. It's better to check 3 and 4. 27 and 32 should be there. So either option C or D. So let me check with option D. 27 by 32. 27 by 32 and into we'll be having 6 by 5. 6 by 4, and we have 5 also, so we need to get rid of this 5. So obviously this is not, so either B or A will be correct answer. Sorry, so 5 by 27 and we will be having 36 by 5. 36 by 5, so this is 36. So 5 and 5 will vanish. This is 3 times and this is 4 times, so you will be getting 4 by 3. So this is nothing but the answer of this lambda is nothing but 4 by 3. This is 1 by lambda. Okay, so option 5 by 27 into lambda is the correct answer. Okay, then next question, if R1 is the value of the Rydberg constant assuming the mass of a nucleus to be infinity large compared to that of an electron, and if R2 is the Rydberg constant taking the nuclear mass to be 7500 times the mass of a electron, the ratio of R2 and R1 is a little less than the unity. Okay, you can check with mathematically. If you know the answer, please comment in our comment box. Okay. Next, in a Stern-Gerlach experiment, in this experiment only the quantization of spins was experimentally proved. The magnetic fields in the plus z direction, the particles comes out of the experiment in 1 plus z state. Choose the correct state. Okay, so the particle has a definite value of square of spin angular momentum. Okay, rest of the things are wrong. So we have it has some spin angular momentum. Okay, in Stern-Gerlach experiment, the atomic number whose angular momentum state is to be determined must travel through inhomogeneous static magnetic field. Inhomogeneous static magnetic field. Okay, only if there's a inhomogeneous magnetic field, you are able to obtain that, do that experiment. Otherwise, if there is homogeneous magnetic field, we are not able to obtain or prove that there exist two states, spin up and spin out states. Okay, so a sodium atom has 11 electrons. If the sequences in this energy levels are filled in this format, the ground state energy. So for sodium, we will be having 11 electron. So we write that as 1s2, 2s2, 2p6, 3s1. So we have 3s1, s is equal to 1, and sorry, s is equal, we have s, so for L is equal to 0 and s is equal to 1 by 2. We can write 2s plus 1 is equal to 2s is nothing but 1 plus 1 is equal to 2. So we will be having 2s 1 by 2. So 2s 1 by 2, this is the ground state of our sodium atom. Okay, positronium is a hydrogen-like bound state of a positron and an electron. If the nth energy level of hydrogen atom is given by ENH is equal to, so this is the energy of a hydrogen atom, the nth energy level of the positronium, okay, they ask for positronium, of positronium will be equal to. Okay, so what will happen since positronium and the electrons, they are electrons is positron is an antiparticle to an electron. So what we do is, if we just find the reduced mass of the system, right? So we have mass of electron is equal to mass of a proton. So we can write reduced mass is equal to mass to mass plus mass. So we will be having m square divided by 2m. So we will be having m by 2. So reduced mass will become, that is m becomes m by 2 in the case of positronium. In the case of positronium, positronium is different from positron. Okay, right, combination of positron and electron makes positronium. So the mass becomes reduced. So as a result of that, what happens is, so the energy of the positronium, which is nothing but, so half of your energy, nth state energy of your hydrogen atom. So option A is correct. Okay. Right. Suppose one bombards hydrogen atom gas at room temperature with electron of various energies. As the energy of a bonding, sorry, as the energy of a bombarding electrons is increased, the wavelength of the radiation first emitted from the gas will correspond to, which is the longest wavelength of in Lyman series. Longest wavelength in the Lyman series, because n value will become very small. In since we have n is small, we will be getting longest wavelength in the Lyman series. Okay, so atoms with off nuclear spin cannot have electric dipole interaction. So we will be having magnetic dipole interaction in the case of half nuclear spin, but they should not have electric dipole interaction. Okay, so rest of the things we have hyperfine structure and fine structure we have because of nuclear spins. Okay, so for an atom in the state 2d 5 by 2, the law is G factor. So we know the G factor formula, which is nothing but G equal to 1 plus J into J plus 1, J into J plus 1 plus S into S plus 1 minus L into L plus 1, L into L plus 1 divided by 2 J into J plus 1. So this is what the formula is. So from this spectroscopic notation, we are able to tell what is the format is. So this is the general formula for your spectral notation. 2s plus 1 is equal to 2 here. So s is equal to 1 by 2 once you solve this. And you will be having L is equal to 1. Okay, L is equal to 1. And J is equal to, sorry, SPD. So 0, 1, 2. So L is 2. So L is equal to 2 plus 1 by 2, so it is nothing but we have 5 by 2. So once you solve this, so you'll be getting 1 plus j into j plus 1. J is nothing but 5 by 2. 5 by 2 plus 1 is 7 by 2, and plus 1 by 2, 3 by 2, minus L is nothing but 2 into 3. 2 into 3, and 2 into 5 by 2. 2 into 5 by 2, 7 by 2. Okay. Once you solve this, you will be getting 1 plus 2 by 10, 2 by 10. So you will be getting 12, 12 by 10 equal to 1.2. So option C is correct. Option C is correct. The doublets observed in an alkalic spectra are due to spin orbit interaction of an electron. Okay, so this is a known one. It's a spin orbit interaction. Otherwise, we don't have. So the possible values of total angular momentum, quantum number of a single F electron are. Okay, so let's check with the values. So F electron. So sp df, single F electron. So 0, 1, 2, 3. So L takes the value of 3, and S is equal to plus or minus 1 by 2, and L is equal to 3 plus or minus 1 by 2. So if you make a plus, this will become 7 by 2 and 5 by 2. So you will be having 7 by 2 comma 5 by 2, which is option A, right? So the de Broglie wavelength associated with the neutrons in thermal equilibrium with matter at 300 Kelvin. So it's a de Broglie relation. We know lambda is equal to h by p, and here we have temperature. We can write it as h by 3 square root of 3m kBT. Kb is the Boltzmann constant. T is the temperature in Kelvin. Okay, so you just substitute these values and you are able to get 1.79 angstrom. Okay, 1.79 angstrom. Okay, so for this we will stop here. So we will try to, sorry, you can solve this problem and you can upload your answer in your comment box. Okay, so this is our second video in atomic and molecular physics. So keep revising physics and keep learning physics, and please do share, subscribe, and comment in our comment box. Okay, and subscribe our channel. Thank you very much.